What is SETI looking for on a planet? A lot of times when they're looking for exoplanets, a lot of the stuff is focused on the star itself because that's easily measurable from the light that we measure from Earth. But some of the factors that may determine if a planet's habitable may be based directly on the planet itself, such as the size and how the internal structure of the planet may work. Planets, like in our own solar system, we have planets like Venus and Mars and Earth. Venus is a runaway greenhouse effect, which has no chance of having life and is about the same size as Earth. Earth has life. Well, we live on it. It has liquid water, frozen water, and gaseous water. So a planet that supports those may be what constitutes life. But when we're actually getting to the point where we can actually measure the contents of other planets' atmospheres. What what keeps the stuff in these three phases? The solar radiation could give us enough, but it's actually the greenhouse gases that trap a lot of heat into the Earth's atmosphere. In the atmosphere at the same time, we're on the planet at the same time. Uh, a lot of people think it's plate tectonics, the subduction and the release of carbon dioxide from the inner layers of the planet itself. This could release carbon dioxide and other greenhouse gases, which could cause the atmosphere to stay constant. There have been times when there was not enough CO2 in the atmosphere where the entire planet was a giant snowball. This is after the original plants consumed all the carbon dioxide and turned it into oxygen. Then animals came about. Mars, which is considerably smaller than the Earth, may not have had enough mass to keep the core, to keep the outer edges of the planet moving with plate tectonics and the entire the surface solidified. And the thing is there's other candidates. There might be microbial life underneath the icy shells of planets, like or moons of the planets like Jupiter, like Europa. May have probably has an ocean bigger than all the water in the world underneath its icy shell, and be powered by radio decay. Like our own core probably has a lot of radioactive decay, keeping it warm from the inside. Other moons that could be this is Enceladus, which is around Saturn, which has been seen to have geysers that have gone hundreds of kilometers into its atmosphere or into space. Or you could have planets like a moon like Titan, which has a heavy methane atmosphere, has liquid pools of methane on the surface, and the outer shell is ice with a ocean underneath that may act like a mantle, and then a solid core underneath that may have radioactivity there. So what would constitute ideal? How would you be able to find these factors on other planets? Like if you had an atmosphere that had oxygen and we had you could detect liquid water, gaseous water, and solid water on the surface of the planet. That would probably, but these factors may be able to determine if there's life on it. Is the planet itself, not just where it's located around certain stars or how much radiation it gets from certain stars. Plus, another thing would be tidal interactions. A lot of the moons of Jupiter and Saturn are in a configuration where Jupiter pulls on it and the moons and further orbits pull on it, so it kind of squishes the planet into creating a liquid water underneath, along with stuff like radioactive decay. So these factors may be actually very important factors in figuring out whether or not a planet has life on it. It's to figure out the probability of a system has life, you may need to figure out these quantities or qualities of the system or of the objects. Okay, that's all I think. Have a good day and bye.